Astronomical Observatory of Belgrade in Serbia. And I would like to talk about the usage of anomalous Cepheids and type 2 Cepheids as distance indicators in the future observations of LSST. Why is this important? As in the past few years, we have seen that there is an increased debate about the exact measure or exact value of the Hubble constant, which is shown here on the panel. As one can see, if depending on which method do we use to determine the Hubble constant, the differences between methods are different enough so that one can say that we should look into whether this is a realistic problem or is this something due to the systematics of the measurements. What I'm proposing, as seen here on the other panel, is that not only can we use the classical Cepheids and the R library, but we can also use other specific types of variable stars. This proposal to use type 2 Cepheids has already been out there. This is not my original idea. So as one can see, for example, there is a paper by Daniel Magès or by Anupan Bhattacharya, and also the group of Giuseppe Bono, which all suggest that using type 2 Cepheids as extragalactic distance indicators is actually doable, and it is also in some ways even better than using classical Cepheids, since in the near infrared, the period luminosity relation that they follow actually misses the problem with the infrared, with the reddening. So what are these stars? In the color magnitude diagrams from the Gaia DR2, we can see that these stars we are interested in are actually in this region. So the type 2s are marked with these orange dots. And considering their evolution, type 2 Cepheids are here. So comparing them to the classical Cepheid, as we can see, these are relatively intermediate mass stars, and as they evolve, they cross the instability strip, and they do this. While they do this in the instability strip, they pulsate, and they're very bright when they do that. So they get up to 50,000 more luminous than the sun. They form a period luminosity relation. This is comparison of the Gaia Hipparcos and then Gaia different data releases up to EDR3 for the classical Cepheids and also for the R-Lyra stars. So the R-Lyra stars are very similar to type 2 Cepheids, only they are much more numerous, and they can be found on the horizontal branch. The anomalous Cepheids are actually stars that are somewhere a little bit higher in mass than the sun, and they also cross the instability strip, while the type 2 Cepheids are actually crossing the instability strip as they leave the horizontal branch, and they can do that in different ways, and this is how we separate them by their periods. So there are three different type 2 Cepheids separated by their periods. They form a very nice period luminosity relation, which can be seen here in the OGLE data. And also, if we look at their period luminosity relation in the infrared band, this is the K band, it is actually very nice. And for the short period ones, it is quite precise. These are the RL stars. These are the classical ones. The ones that we tend not to use are the long period type of Cepheids. But we can do even better than that. We can have the bolometric magnitudes, which means that we have measured the radiation emitted by the stars throughout the whole spectra, thus eliminating again the problem with whatever is happening in the infrared. And this is the period luminosity relation plotted, and these are the relations actually for the anomalous Cepheids and the type 2 Cepheids calibrated for the distances of the LMC. As one can see in the Gaia DR3, the number of anomalous Cepheids has skyrocketed because previously only a few hundred were known, and now we know more than 15,000 only in the Milky Way. So what one can say is that since the number of detected anomalous Cepheids has increased significantly, they are also a very plausible candidate for using them as alternative distance indicators. And to end, I think we can add these two very specific type pulsating stars to the family of extragalactic distance indicators because they can be used up to 10 megaparsecs. They can be found in galaxies and dwarf galaxies as well. Thank you for your attention.